Alright, so we are about to learn the most magical concept. We're going to be able to make our code, which normally looks like this. We're going to make it, drumroll please, do that. We're going to make code that comes back around on itself and starts rerunning code that has already been executed before. Maybe a second time, a third time, a fourth time. It's going to be amazing, okay? So this is very useful. It'll solve that guess the number problem that we were having before. And oh man, it will save your life one day. So let's talk about loops. Let's get right on into it. So to motivate this topic, I think that guess the number game is a good example, right? We've been copying and pasting way too much code. We don't need to. We just want to rerun that same code, write it once and have it rerun. Yeah? That's the goal. So right now our programs, they can look like this. We've learned how to write code that executes one after another, lines that execute one after another. We have the ability to branch off right now and then do one thing or another, maybe 3 lines on this branch and 2 lines on this branch. And then we know how to come back together and maybe do some more straight line code. That's as cool as our programs can get right now. But we want to make them cooler. We want the ability to execute code in order, to be able to branch. We already have that. And then we want to be able to wrap back around and rerun that fancy code some more. And that's a loop, and that's where we're going. All right? So let's make programs revisit and rerun existing code. All right? That's our goal. Because our programs could be cooler. They're straight lines and branches, but this is where we're going. We'd like to add these things called loops. So let's do that. The simplest loop is called a while loop. So here's the code. It looks very similar to an if statement, right? You just say while instead of if. You still put a Boolean expression here, but it gets repeated. This body gets repeated while that expression evaluates to true. So let me try and explain that. Repeated while that expression evaluates to true. Alright, so this is what the code will look like. If you make a while loop and you have some Boolean expression, this is how it runs. Very similar to an if statement. It's like you come in through it from before, from your ... up here. And then the very first thing in a while loop is always check the condition, because it needs to know, it needs to execute the body while that condition is true. So it's like, should I run the body again or maybe for the first time? It's got to check that condition. And as long as it's true, it runs the body. And then it comes right back to the condition again. It's going to repeat. As long as that condition evaluates to true, it'll keep running the body and checking that Boolean expression. And the whole point of a body is to hopefully make that expression become false one day. You're doing some work. Eventually you're going to be done and that expression evaluates to false, in which case you've run enough loops, and then you can go down to the rest of the code. That's how a while loop works. And so that's the syntax. That's how it's going to look in a flow chart. Let me give us a quick demo of printing all the numbers from 1 to 10. So let's print every number from 1 up to 10. And of course you can change this to print from 1 to 1,000,000. This will be a good first example, I think. So let me make a new folder for today's code. But I have to write one body that prints 1 the first time and 2 the second time and 3 the third time. That's a little weird. I have to be running the same code and have it print a new number each time. So think about that. How might you do that in your mind before I show you the answer? We're CSCI 40. And we are lecture what today? Lecture 6? Yeah, so let's make a new folder for like 06. Go in there and make it large. So I'll call this 1 to 10.cpp, let's say. So here's the magic of a while loop. So I would like to do it this way. Let's always have a variable that tells me what I want to print right now. So let's start that variable. We'll call it I for a reason. That's a very common variable name when you're using loops. So I'll call this variable I. And 1 is the first thing I want to print, right? So I'm going to say while, I'll figure out the condition in a second. I want to repeatedly print I, so that's going to be a cout, and then I want to increment I, because the next time I come back in this loop, I don't want to print 1 all over again. I want to print 2 the next time. And so the code that can be repeated is print I and then I++. See that? Increment I by 1. That is the goal. So do you see how the first time we go into this loop body, we'll print 1, then it'll be 2, I will become 2, and then when we come back, we're printing 2, making it 3, printing the 3, making it 4, printing the 4, making it 5. That's beautiful. And now the question is, when does this need to stop? When should we be done printing all the numbers from 1 to 10? It's like, all right, while I is something, keep printing. And the right answer is going to be involving the ending value. So I want to go up to 10. So as long as I is between 1 and 10, it starts at 1, as long as it's less than or equal to 10, I want to go in this body. I want to print I, add 1 to it. That's going to be how this works. Okay? Dun, dun, dun. Those of you who are talking, can you just please talk on Discord or something? I can't think when I hear your voices. Thank you. So let's go 1 to 10.cpp-o 1 to 10. 1 to 10. And what do you know? I get 1 through 10 printed out. Are there any questions about how this code is working? So I'm making a variable. It's very weird. I'm making a variable, and I'm repeatedly using that same variable to print a different number each time. So as long as I is less than or equal to 10, I'm printing 1, making 1, 2, printing 2, making 2, 3, coming back as long as it's a number that I care about printing. Any questions about that? It's really fancy, very useful. All right, so let me draw. Let me draw what's going on here. Let's screenshot this. All right. So here is all my words in picture form. Okay, so let's watch this work. So I have the I variable, and I'm starting it at 1. And all right, is 1 less than or equal to 10? Yes. We're checking that condition, running the body if it's true. So yes, 1 is less than or equal to 10. So I will run these 2 lines once, at least once. So I'm going to print my I, so that's why I see the 1. And then I say I++ to make I2. And now we go right back to the condition, because that's how a while loop executes. As long, after it does the body, it always goes back and checks the condition once more. Is 2 less than or equal to 10 now? Is the new question. Yes, true, so it'll run its body. All right, so now I'm going to see 2 in the output, and I'm going to say I++ once more. So now it's 3. So do you see the game that we're playing here? So is 3 less than or equal to 10? Go back to the condition. Yes. Print I++. Is 4 less than or equal to 10? Yes. Print I++. And so you can imagine, like, we're going to print 9, make 9 10. Is 10 less than or equal to 10? Yes. Print I++, so 10. And then we make I 11. And this is what stops it, right? So we go back to the condition one last time. I is now 11. Is 11 less than or equal to 10? No, false. So that stops our loop, and that continues the rest of the code down here, okay? That's how that's working. Any questions now that we've seen that idea in action? Because that's one example. I also want to show you how easy it is to use this same idea to compute the sum of all the numbers from 1 to 10. So like if I want to not just print them out, I want to keep track of their sum. What is the sum of all the numbers from 1 to 10? I can do that very easily by introducing like a sum variable. Starting it at 0 and then just repeatedly adding like the value of I into it each time. That will be my goal. So let me show you that. Let's see here. I'm going to walk through how that works. So let's call it, instead of, we can copy and paste most of this. Instead of I, let's use j this time. And we'll have j range from 1 to 10, j++. And instead of printing the value of this j this time, I'm going to repeatedly add j into a sum variable, in sum equals 0, let's say. Right? So that's the goal. So I want to repeatedly add j into sum 10 times. And then also like make it 1 the first time, 2 the second time, so I want to increment it each time as well. Increment j each time. That's going to be our goal. All right? So in the loop, I want to, like, j is set to 1 the first time. Let's add 1 into sum. Sum equals itself plus j. Sum equals sum plus j. And so that'll add 1 into sum the first time. And then I'm incrementing it to 2, so the next time we hit this loop, it's going to add 2 into it first time, 2 the second, 3 the third time, dot, dot, dot. I hope that makes enough sense. But watch. Watch what's going to happen. At the very end of all this, it's going to add 1 into sum, 2 into sum, all the way to 10 into sum. And j is going to become 11, and that'll stop our loop one more time. And then after that, we have a sum variable that we can go and print. So let's separate these ideas with a new line. And now sum has a value in it, and it is the answer. That is the sum of all the numbers from 1 to 10, which is apparently 55. We can check that with math if we need to. But this is what's going on. This is what this code is doing. We have j starting at 1. And every time we run the body, we're adding j into sum. So the very first time, sum gets to be itself plus j, which is 1. Make j 2. Then we add 2 into sum. Sum equals sum plus j now. Now it's 3. Make it 3. Add the 3 into sum. Now it's 6. Do we see how that's working? And so eventually it's going to be like, we add dot, 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 10 into sum. Now it's 55. And then we make j 11 one last time. And that stops our loop, because we are continuing. We're doing that adding process as long as j is less than or equal to 10. And now it's 11. That's not true anymore. So I'm done. Now I have the value that I want in my sum variable. All right? Any questions about that one? If we are happy, let me give you my first piece of code that I copied and pasted from a previous semester. It's the same code, but take this. And you don't have to write this down anywhere. Just try it yourself on the class server, maybe. But take this code that prints from 1 to 10, and see if you can change it to print from 10 to 0, even numbers only. Can you print from 10 down to 0? So what would you have to change? So think about what's going on, what each of these lines are doing, and see if you can get it to output this instead of 1 through 10. All right? Questions about the question? All right, yeah, take a couple minutes. Please help each other, say hello, and see if you can get this working. You're definitely allowed to talk now. So 10 down to 0 rather than up. So we were going up, so figure out the part that didn't go up. We go down instead. The first thing that we printed was 1. 1 to 10, so we went to change that. Start somewhere else. And then you want to stop at 0. What's a good condition that's going to be like, alright, if I ever get something different, how do I stop it where I want it to be? Oh, and if in the process of doing this, something goes wrong and it keeps printing forever, Control-C. Type Control-C on the terminal to stop the program. Take another minute or so, and then we'll discuss. All right. A couple more seconds. Do we all do attendance? After I finish explaining this question, I'm going to stop attendance too, so please do that. All right. So, do any brave souls want to tell me a piece that they changed? Yeah. So what's one thing that you changed?
One thing that I changed?
Yeah.
I changed the plus plus to minus.
Oh, very nice. So yeah, we want to decrement. So minus minus. We'll decrement by 1. Okay. I think we might want to decrement by 2 though.
Oh.
We're going down by 2 each time.
I missed that bit.
Yeah, that's pretty much the answer though. So this line better change. We better decrement by 2 rather than increment by 1. Good. Anybody else want to tell me another piece that they changed? Yeah. Very good. So that's our starting value. The first time we hit this body, we're going to print whatever I is initially. And if it's 1, we're going to print 1 first. Very, very good. So we want to change that to 10 instead of 1. And then there's one more piece that needs to change. Does anybody see it? Yeah. Yeah. Very good. And you flipped it. That's a great thought there. So yeah, you got to flip it. And it's still in terms of where you want it to stop. So you still say 0. That's where I want it to stop. But because it's going down, you got to say, as long as it's greater than or equal to this, keep doing that. All right, so that's perfect. So good job, all y'all. Let me show you that in code real quick, just once and for all. Whee. So, all right. I would like to start. I'll use I again. I has already been declared, so I can't say int I equals 1 anymore, but I can just give it a new value. I equals 10. And then while I is greater than or equal to 0, output whatever I is, and then decrement it by 2. So it's I equals I minus 2, or I minus equals 2, something like that. That is our goal, all right? And this is going to do the right thing. So is 10 greater than or equal to 0? Yes, print it. Is 8 greater than or equal to 0? Yes, print it. Is all the way down to 0. Is 0 greater than or equal to 0? Yes, print it. And then it's going to make I negative 2, right? And then it's going to ask, is negative 2 greater than or equal to 0? No. So that'll stop the loop and be done with it. If you forgot to do the change, there will be a bit of an error here, and it will be an infinite loop. Because, or actually, no, it won't even start. It won't even do anything. So that's useful. Sometimes the loop doesn't even run if you get the condition wrong. Sometimes it runs forever. I'll talk about that forever stuff in just a second. But any questions about this and why that's the right answer? I mean, there's a million different ways to write the same thing, but this is a good template at least. All right. So right now, I would like to just have you all pat yourselves on the back because you have learned the last piece that you really need to learn to do things in programming. So this dude named Alan Turing, very famous, very sad end to his life, he invented what's called the Turing machine, which is a model of computation. It's a mathematical model of anything that any computer ever could possibly compute. So every computer program that ever was made or ever will be made can be modeled by a Turing machine. Unless you go to the quantum stuff, and we won't get into that. But our current knowledge of C++, if statements, if else, while loops, and the fact that we can have arbitrarily sized string variables, allows us to simulate any Turing machine. So we can write a simulator for a Turing machine, which means we can create any possible program that has ever existed right now with our current knowledge of C++. Isn't that cool? That's amazing. And so you might be asking the question, let's just end the class now. Semester's over, right? I think you can, I've shown you some things that you still don't know, right? And there are ways to make your life much easier as a programmer. You'd be wasting a lot of time doing things the hard way if we stop now. But you know technically, and you know how to compute any computable function right now, technically. So you should just take a step back and appreciate that idea. So congratulations, all of you. All right. So with that, let's talk about some issues, because the first major issue that you can run into now that we didn't have access to before now that we have loops, we have a new kind of bug where our program just never stops. It's called an infinite loop. Usually you don't want an infinite loop. There's a cute idea. The Apple campus in Cupertino, they built the place, and so they built their own street name, and they called their street name Infinite Loop, and their address is 1 on that street, which is fun. So you get the joke now. But you could say something like, while true, that's the easiest way to get an infinite loop, right? This is a condition that never is false. And so the code within here is never going to stop running if you make an infinite loop like this. Or you can make one much more subtly, too, I promise. But let me show you a case of an infinite loop. Let's make a program that is a bit more subtle than just saying while true. That still, unfortunately, never stops. Let's take our printing from 1 to 10. Let me show you one way that you could have done that wrong. .cbp, paste. Let's just take this part, I think. Print I, increment I by 1. If I mess up this condition and be like, forget that it had to involve the end rather than the start, if I said something like, while I is greater than or equal to 1, print it and add 1, right? Is 2 greater than or equal to 1? Yeah. Is 3 greater than or equal to 1? Every number is greater than or equal to 1 when you go in that direction. So it's never going to stop, at least for a while. If you get to CSCI 45, I'll tell you that it will eventually stop. But let's pretend that it doesn't. Infinite loop. And so you might run into this when you write your code. It's like, okay, it's just counting up. It's having a grand old time. It's never going to stop anytime soon. And so when this happens, if you have like a runaway program, type Control-C in the terminal. Even if you're on a Mac, Control-C. That will stop the program, just like when you're done submitting to the autograder. Stops that program. All right? Control-C will stop your infinite loop, and everything will be happy again. Okay? So you're going to run into that. This is how you deal with it. With great power comes great responsibility. Right? So that's infinite loops. So let me show you some cool programs that involve loops. This is the oldest algorithm on record. It's called the greatest common divisor algorithm. I should teach it to you. It's the first algorithm ever invented by Euclid back in the BC era, and I'm not going to explain to you why it works, why it computes the greatest common divisor of two numbers, but I'm going to implement it for you at least. You'll have to wait till CSCI 26 to get the proof for why it works. Nice. Yeah, so here is what the greatest common divisor is if you've forgotten from math class. It's just like, it involves two numbers. Like, I want to know the greatest common divisor of 12 and 18. What you do, in math class at least, is you like compute the prime factorization, and then you just circle all the ones they have in common. Like 2 and 3, they have a 2 and a 3 in common, and so multiply those together, and 6. That's the biggest number that can divide cleanly into both of them. That's what the greatest common divisor means. It's useful when you're doing like some fancy calculations, potentially cryptography programs. They're using greatest common divisor all the time. So like 6 is the greatest common divisor of 12 and 18, and there's an algorithm that's very efficient that can find that out without having to like compute prime factorization. So here is the algorithm. You make two variables, a and b. Those are the two numbers that you want the GCD of. And then here's the process. As long as b is not 0, you are going to change b to be the remainder of dividing a by b, so like shove that into b now. And then you change a to be the previous value of b before you did this. So you like got to save it away in a helper variable for a second before you took that remainder. And so you just repeat that process, and eventually b will get whittled down to 0. And when that is true, when b becomes 0, a holds the GCD. So that's the idea. So we're just going to translate those words into code. So while b is not equal to 0, you just say while b not equal to 0. Well, that's true. Continue. And then this line is like b equals a mod b, the remainder after dividing a by b. And then this one is like replace a with the old value of b. We gotta save that before we do this, right? A equals old b, something like that. So that's the game, and let's make it happen. It's the very first algorithm ever invented, or ever written down, I guess. GCD.cpp. Way back before there were computers. So let's ask the user for the two numbers they want the greatest common divisor of. Why not? Let's make this a generic program. So cout enter two numbers. And I assume you've seen this already on like your Zybooks or accidentally during the lab, but you can get two numbers at once from Cn. You can be like, space separate them, type them all on the same line. You can say Cn into A and B at the same time. That's possible. So now I have those two numbers, and I'll show you how to type that in the program if you haven't seen that yet. And now we're going to do the algorithm. While B is not equal to 0, you just read it off. While B is not equal to 0, what do? Replace B with the remainder from dividing A by B. So B equals A mod B. And then I need to make A the old B, so I got to save that for a second. So before I do that, what's the old B? That's the current value. Now I'm allowed to change it. And then A equals the old B. There, so that's the order of those lines. And eventually, B will get smaller and smaller and eventually become 0. And after that's done, A holds the greatest common divisor of those two numbers. Yay, so that's the program. It's very simple to write down, but very fast to do this computation. It is, it's a very hard problem to factorize numbers. So this is not involving factorization, and yet it does something that you might think of involving factors. So 12 and 16, or was it 12 and 18? 12 and 18 is 6. So I typed them both on different lines. If you get Cn, if you call Cn twice like this, if you use it on the same line with two numbers, you can just enter them with some amount of space between them. So like 12 space 18 and hit enter, and it'll get them both at the same time. Like that is 6. What is the greatest common divisor of these two numbers? Apparently 11 is the biggest number that goes into both of these random numbers. That's pretty cool. So yeah, that's GCD. Any questions about that? Do we see how I'm kind of reading it? While B is not 0, as long as that's true, as long as B is not 0, keep doing this. And once it's done, we're guaranteed, right, that B must be 0. Otherwise, we would have kept going. Once it's done, B must be 0, and at that point, output A. That's the answer. Cool little algorithm. Let's see, what else do I want to talk about? Oh, okay, we're ready. Do you want to solve that guess the number game? Like, do it right? Have it last as long as the user keeps typing the wrong answer? Have it keep going forever? Because now we can keep asking. We can keep asking the user for a new guess, and here's the condition, while they haven't got it right yet. That's the secret. We needed a while loop. So while the guess is not equal to that secret number, keep on asking for a new number and checking if it was right. Keep on doing that as long as the user's getting it wrong. Help them, tell them which way the right answer is. And then eventually, guess will become equal, and this will become false, right? If guess is equal to number, it's not true that they are not equal. I hope that's a little weird to read it like that, but it'll be false if they're equal, and that will allow us to stop the program without having to copy and paste those lines a million times. Okay? So let's do this right, and this will be a good game for once. So let me copy in, how do I want to do this? Let me copy in last time's, lecture 5's guess.cpp. Oh, sorry, copy it here. And let me edit it to like get rid of all this junk that we did before. So keep a lot of it. Keep this srand, keep a number. Still got to ask the user for a guess. But here is the goal. Only have the asking and checking happen once, so that this is not a 200-line program. All right? So here is the asking and checking part. I want to put that in a loop as long as the user hasn't gotten it right. All right? So I'm going to say, while guess is not equal to num, or I guess it's n in this program, while guess is not equal to n, then do all this. Okay? And so it'll just, as long as the guess is not equal to that special number, it'll ask for a new one. And then if we got it, they'll finally be equal to it. And I don't have to say x anymore, because once they're equal, the loop will stop. And then I can return 0. That's beautiful, all right? So there is a bit of a problem. What do we think is going to happen the first time you run this body? Because like I've picked my secret number. I've declared but not initialized guess, and right here I'm checking this uninitialized variable to see whether it was equal to n. That's not good, right? So this could be anything. In fact, randomly, we're getting some garbage value. It could be the case that the very first value of guess, this uninitialized value, is set to the secret number that I'm thinking of. And so it's going to be like, you got it, or it's not even going to ask for anything. It'll end the program. So that's unfortunate. What we should do, we should always, before we use our variables anywhere, initialize them to something. I want to make sure that the user is asked for their first guess. So let's just initialize guess to be a number that will never be the secret number, like -1, because I'm guessing a random number between 1 and 100. So guess will never be, or n will never be -1. So let's start guess at that to make sure it's not equal to the very first time, okay? Because then it'll ask and it'll all work out. Does that make sense? Gotta watch out for those uninitialized variables. So, g++ guess.cpp-o guess. It really will work this time. So /guess. So the very first time it's not equal to, what is our guess? 50. And I can keep, and it's too low, enter your next guess. I can keep entering 50 until the end of time if I was a bad player of this game. Okay? And it would never stop. Because this is going to happen as long as the guess is not equal to n. That's exactly what we want here. Alright? But now we can do it right. 75, too high. 64, too low. 70. Okay, apparently it was 70. And see how, once I get guess, and it ended up being equal to the n, they were both 70 at that point, it does go back and it checks the condition once more. Like, should I run the body again? But no, now it's false. Guess is equal to n, so asking if they're not equal to is a false statement. It's a no answer. They are not equal. That's kind of how you think of it. And so that'll stop this loop. The loop is done at that point, and then the program ends. So that is the correct guess the number game. Are there any questions about that? So now it works. You can give the user as many guesses as they would like, which is beautiful. That's what we want. Let's see here. If we're happy with that, I do have a new topic. I want to teach you. There's two kinds of loops in C++. As far as syntax goes, we did a while loop. There is another kind of loop that you may grow to prefer for certain things, and that will be the next topic if we're happy. All right. So it's called a for loop. All right. It looks like this. It's a little weird looking in that between these parentheses you put several lines that are semicolon separated. It's very weird. And then notice that there's no semicolon after the last line, the last little thing. So that's a little odd, but just remember there's only two semicolons, they're separators. So this is what a for loop looks like. For, there's an initialization part, this is what I like to call it at least, initialization, then you put a condition like you would with the while loop, and then you put what I like to refer to as an increment piece, and then again you have the body between the curly braces. All right, so that's what a for loop looks like. Any for loop, it corresponds to a while loop. A while loop is more general. A for loop is just a special kind of way of looping. You can do the same thing with a while loop, though. For loop gives you no extra power. It just makes some things slightly cleaner looking, I guess. So here's how a for loop works. There is, like, you come in through the before, so that's the code from before, and then the very first thing you do for the loop itself, for the for loop, is you run this initialization part. So that's the very first thing that gets run, and notice that it's never going to get run again. That's not part of the actual looping part. Here's the looping part. The initialization just sets it up. This line only happens once, so you can put code here that only happens once, that sets things up for your loop. And then you have the condition gets checked just like a normal while loop. So then it checks the condition. If it's true, it runs the body, just like a while loop. But then after the body's over, it always makes sure to run this increment piece that I call. So it's always going to run the increment statement after the body, and only then does it come back to check the condition. So it's condition, as long as it's true, it's going to run the body as well as that increment piece. That's what's going to get looped as long as the condition is true. All right, that's a little weird. It'll make sense in a second, though. And then, just like with a while loop, the second the condition becomes false, the whole loop is over. We go to the rest of the code down here after whatever's down there. So that's how that works. It is odd. And that's the execution diagram. So let me do 1 to 10 printing all over again. And I'll show you the difference. So let's do, let me steal the while loop so that you can see it at the same time. So let's copy and paste. Let's make a 1 to 10 underscore 4.cpp file. And so here's the original while loop. And watch as how I'm going to change this into a for loop. All right, it's essentially the same code, it's just you put them in different places. And I promise that one day you might grow to prefer the for loop for this kind of print from 1 to 10. All right, so here's how you do it. For, what do I need to initialize for this loop? I want an I variable, and I want it to start at 1. That's what goes in the initialization part. So for int I equals 1, I'm declaring a variable. I'm putting code right there in the initialization part, semicolon. And then what do I want to do with I? I want to do the body as long as I is less than or equal to 10. All right. And then after I do the printing, I want to always be sure, that's the condition, after I do the printing, I want to always be sure to do the next value of I. So I'm going to put the increment statement. I'm going to put the plus plus right here. That's how I get the next value of I want to work with. And now the body just becomes CRI. So that's the for loop equivalent of this while loop. You see it has all the same pieces. This is where the initialization goes. Here's the condition. Here's the body. And then after the body always runs this increment part. So you put it there instead of as part of the body with the while loop. And the reason people like to look at these and prefer them sometimes is that you have extracted dealing with I into the first part and initializing it and having it range between the proper values and the proper order with the right steps, like increment by 1. That all goes up there, and then the real work that you're actually doing with I goes here. So only the real stuff, the real work that you care about doing goes in the body of the for loop. It's I want to print whatever I is right now. And so you can read that off very easily. It's all right, it's manipulating I's ranging from 1 to 10, and I'm printing that value every time. That's how you kind of read it. But a for loop is nothing new. It's all the same as a while loop. So the for loop doesn't give you anything extra. It just gives you a different way of arranging the same code. Okay? And some people prefer it because it's all right, I starting at 1, and it's ranging from 1 to 10, incrementing by 1 each time. You can see that in the first line. You don't have to go look in the body for that. And it's I'm messing with I. I'm printing I. That's what I'm doing. Okay, so let's run that and watch it do the same thing. -1 to 10, this is a weird name, oh well. 1 to 10 underscore 4, and let me resize so we can actually see all this. And so there's my 1 to 10 printed out. It really does the same stuff. It really is working out. So let's watch it work some more, just get some practice executing this code in our minds. Here's the code again. It's doing exactly what the while loop did. So it's starting, the first thing it does is it runs the initialization. That happens once. Initialization is the first step. So it makes that I variable, sets it to 1, and then it's repeating condition body increment as long as the condition is true. So, all right, is 1 less than or equal to 10? Yes. Runs the body, prints the value, so the screen has 1 on it now, and then it increments I with the I++ part to 2. And then it goes right back to check the condition again. Is 2 less than or equal to 10? Yes. So, all right, run the body, run the increment. Print the 2, I++. Is 3 less than or equal to 10? So it's going to keep on doing condition, body, increment, condition, body, increment. Prints the 3, makes the 3 4. ... I think you get the idea. So eventually it's going to get all the way to 10. Print the 10. Is 10 less than or equal to 10? Yes. Print it. Increment it. So now I is 11, and as usual, goes back to the condition. Is 11 less than or equal to 10? No. I'm done. So it's not going to run the body. It's going to jump to the rest of the code down there. All right, so it's just the same as the while loop, but it's it's kind of in a weird space. It's this, then this, then this, in that order. Any questions about that? It's new and weird. So that's a for loop. All right, if you're happy, it's your turn again. So here's this loop again that prints from 1 to 10. Change it to print from 20 to -5, counting by 5s this time. Decreasing by 5s. See if you can figure that out. I'll give you a few minutes. Help each other, please. So we're counting down again. This code is counting up, so we have to change that, definitely. So you gotta change all the same things. They're just in a different place now, right? It's like, all right, I want to print 20 first. So that value is we were incrementing before. We're going to the next value, one more. Now it's got to be 5 less. Yeah. Those are like the 3 main pieces. But notice how you probably don't have to change the body. You just got to change how I gets manipulated. Take another minute or so, then we'll talk about it. Alright, that's my timer. Alright, any brave souls willing to share a piece that they needed to change to get it working? Yeah. Greater, very good, yes. Because we're counting down, we do have to change the way that this is working. So while it's greater than or equal to -5, we want to keep going. Because if it was less than, and you started at a different value, I think the loop would never even start. So yeah, that's very good. That would need to be I is greater than or equal to -5, involving our stopping condition. And because we're going to be moving down towards 5, once it gets any smaller, that's when we're done. That's how you change it. Good. All right. Anybody else willing to share another piece that they needed to change? I can share one. So if we want to print 20 first, we better initialize I to 20. Yeah? So there's one. There's an easy one. And then, so it starts at 20, and as long as it's greater than or equal to -5, and that's true to start, right? 20 is greater than or equal to -5. Keep on trucking, printing our value of I. All right? What's the last piece? What we got? Yes. Oh, nice. Yeah, you're using the shorthand. I like that. So yeah, we want to change this to decrement I by 5 rather than increment I by 1 like it's doing right now. So we would like to do a line that's like, here's the full form of that. That would be I equals I minus 5. And you can do the shorthand exactly like this. You could say I minus equals 5. Minus equals 5. And that subtracts 5 from I. It's a cool little shorthand. And remember that I++ was equivalent to I equals I plus 1, which is equivalent to I plus equals 1. You got all those options. But when it's more than 1, you can't use like I minus minus and then just like type 5 minus signs or something. That won't work. So yeah, that's all that needs to change. That's it. And notice how it's just ever so nicely placed in the first line of the for loop. All we needed to change was how I was ranging. And that's what for loops give you control over very easily. Just at the start, this is how I ranges, and then here's what I want to do with I. That's what the body contains for a for loop. That's some people prefer that. Yes, question in the back.
So how would you, if you were to say to get an average of all the time, how would you do that?
Do you know how to do it with a while loop?
No.
I think you would want to start with a while loop first. Because then it's very easy to translate that to a for loop. But if you want to, like you're saying, you want to range through these numbers and average them?
Like, for example, you want to get the average of 20, 15, 10, 5.
Okay, yeah. So let's go back to our sum code, because an average is pretty much add up a bunch of numbers and then divide by how many you added. Yeah. So here would be the while loop form of that. Let's see, how do we want to do this? So here's this code that summed all the numbers from 1 to 10. And so to easily calculate the average, be like double average equals sum over 10.0, something like that. You'd add them up in your range and then divide by how many you put in there. And that would give you the average. Is your question about the strategy for finding an average like this, or is your question about making a for loop that does this?
I think that answers it.
Okay, yeah. Because then you could change this. Oh, sorry, yeah.
Couldn't we also do sum divided by j?
J would be 11 right now, though. Yeah, it would be too big. And then also it's an int, so it would be doing integer division. We want to do double division with, because you don't know what an average is. Averages usually have decimal places, right? So that's a great question. And then this would be able to translate into a for loop, right? You could have it range from 1 to 10, adding into sum each time. It's just that this would be your increment. The sum equals sum plus j would be the body of that for loop. So yeah, that was a great thought. Thank you for that. Any other questions? Let me go back to the for loop program on this slide. We getting it? Slowly but surely? Nice. Okay. I guess in the spirit of talking about things that could go wrong, here are some other interesting quirks of C++. Let's talk about variables and their scope, we say. So scope, that word just means it's talking about which variables are alive at a given time. And by alive, I mean like you can print them, you can use them. Because sometimes you have variables that exist, but they're not things that you can access anymore. They're out of scope, we say. So the main place where you create scopes are braces. So like in an if statements body, in a while loops body, in a for loops body, you can create variables there. And those variables actually only live between those enclosing braces. So it's a little weird. It's like here's like your main function or something. You say like int I equals 42, and that lives for the life of the main function. But maybe, like here's main's closing brace way down here. But maybe you make like an if statement, and that if statement has a body with some curly braces. And like you say, or maybe you make a loop. You're like int I equals 55 or something, and I++, or this is part of it. Anything with curly braces, honestly. Notice how this is okay now. I can make, first of all, I could have called this j, but you can totally make a variable called I in an inner scope. And this I, like if you tried to print I right here, it would print the 55 rather than the 42. Because this I gets priority. It's closer to you. It's in the inner scope, we say. It's really weird. I'll write some code for this in a second, but that's the game, all right? You can do that. That's no fun. So, and then you can come down on like a different piece, and you could make a variable with a different name. You'd be like int j inside of like the body of a while loop. And do stuff with j. And then the closing brace of that loop or whatever, j goes away. There is no j down here anymore. J does not exist for the rest of main after its enclosing brace, because it goes out of scope. It dies essentially, all right? So yeah, the variables that you make only live between their enclosing curly braces, and you can totally make a variable in an inner scope with the same name. It just shadows the other ones. Like, here's I equals 42, all nice. Then when I'm in the green part, I can totally make an I that holds 55 or something. It's a separate I. And this is the one you get when you're within the green braces. It's really weird. So just watch out for that. I guess the secret is just don't use variables of the same name multiple times. That's going to save you from this. But then, yeah, the second you do I++, that's working on this I, 56. But once you hit the closing green brace, this I goes away, and now if you ask for I again, you're getting the 42. And that might not be what you expected, so just know that now. And then same with this J. J exists within its braces. Like, here's J, it gets values, we do things with it. But the second we hit its closing brace, it goes away. It does not exist for the rest of the code down here. All right, so let me show you that. It's very weird, but I think an example will help. I'll just take over the rest of this file. So we're already here. So actually, you don't need a while loop or an if statement to make a scope. You can just start writing braces inside a main. It's fine with that. Don't really want to do this, but it's helpful for the example. So int x equals 42, see out x. And then what was I doing? I'll make another x in an inner scope here. So here's an inner scope. Int x equals 55. See out x. Disgusting, I know. Let's make an inner scope. Int x equals 100. See out that x. Oh man. And then, as all of these scopes finish, closing brace, let's print out x again. What's x now? All right. So here's all this, and try to see what's going to be printed. See if you can guess the right answers. Are you ready? Whee! So let me zoom out for a second so you can see most of this. I'm trying my best here. So here's the outermost scope, and can I scroll up here for a second? No, this is not easy. So there's the last 10. This is the output, the relevant output. So here's my first brace. Int x equals 42. Obviously, this is going to print 42. Inner scope, int x equals 55. Sure, now that x gets priority. It'll print the 55 when I ask for x. It has no way of accessing this one anymore inside this scope. And then we make this one. Int x equals 100. Print that x. Cool. Then we see 100. And then watch, the scopes close, this x dies. The 100 is gone now. So when I print x here, it's getting the closest x now that's still alive, which is the 55. Do you see that? This is disgusting. And then we go down even further. That scope ends, so this 55 dies. And so this x, we print it. It's just the closest one that still is there, 42. All right, so that's what we get. Any questions about that? That is the weirdest thing ever. Watch out for that. Watch out for making variables with the same name. No fun. Also, I made that 42 in an inner scope. So, I cannot ask for x in the rest of main. If I ask for it here, I'll get a compiler error. It's like, x was not declared in this scope. Ooh. It's almost like these words. Other people use them too. So there that is. So that's what that means when you see that. X it's not alive anymore. There is no X after the closing brace. After this brace right here, X doesn't exist. Unless you made one out in main. Okay. Any questions about any of that? And so that's the same for a for loop. Alright? The same for this for loop. Because the I is being made as part of the for loop. It's its own little scope, surprisingly. So I can't ask for I like I could with a while loop, because with a while loop you can make it outside. With a for loop you make it inside, and this is part of the for loop scope. So cout I also won't compile. It only lives within the for loop. It dies once the for loop is gone. Once it's over. So this line doesn't work either. I is out of scope at that point. Okay, so that's why we need to learn about it, because for loops create their own scope, and you might be wondering, like, can I access I after this is done, like I could with a while loop? You cannot, and that's the reason. All right, we're good with that? That's a fun little thought. Now you know. And if we are happy, I have one last trick for the day, and this is a very good example of when you would want to use a loop for something meaningful. All right? Let's get a string from the user, some word, and then no matter what was there, oh, we don't want to see it, apparently. You know what? This happens on the hour. This happened yesterday, this happened the day before, and then I looked at the time. It is 3 o'clock right now. And so this is why it stopped working. I don't understand. It just kicks everybody off on the hour. But let me unplug this. That's part of the secret. Let me connect. Okay, sure. I'm gonna have to talk to IT about that. But that's silly. This room is haunted. So sorry about that. But yeah, I'm gonna get a string from the user, and it's gonna be of arbitrary size, right? The user could enter a giant word or a tiny little word, and I would like to lowercase it. Like maybe they typed it in all caps. I want to lowercase every character in that string, regardless of how long that string was. And this is a great example for using a loop. Okay, so here's my string s. Like the user types an all caps word. This is what I want to do to it. Like they type blah in all caps. I want to go in, and I want to change every single character of that string, no matter how long it was, to lowercase. All right, that's my goal. So first of all, some terminology. I'm going to use a loop to change every character at every index of this string. First of all, that's going to be how I do this. So like here's index 0, 1, 2, 3, up to the last index that we know how to calculate now. I'm going to change every value there to its lowercase character equivalent. And the process of doing that, the process of visiting every index in this string and messing with it, is called the idea of moving through the string one character at a time. We call that iterating through a string, right? When we visit all of its indices. That's like, comes from the word iteration, which is like has a Latin root going back to the word to go. So it's like we're going through the string, right? We're iterating through it, and we're visiting all of the indices. So every time you make a loop, there's usually something you're iterating through. Like I is ranging from 1 to 10. We're iterating from 1 to 10. That's why we say it, right? So we use that word a lot. And yeah, so here's the game plan for this. We're going to visit every index of the string, starting at index 0, of course. And so that's why you usually use the word I. One of the words that I is short for is like the index that I want to visit. So that's why you call it that usually. So we're going to start I at 0, because that's the first index of the string, and then we're going to go up until the last index. And we're going to call toLower. Remember that special library helper function? We're going to call toLower to change the character from capital to lowercase. All right? It was CC type. The CC type library. This is where it lives. Yeah, good question. CC type. So we're going to include that. And yeah, so every time like we're in the body of our loop, we have I set to the current index that I want to change. And so I'm going to do something like this. I'm going to say S at I. I holds the index that I want to look at right now. Set that to the toLowered version of itself. That's what we're going to do. All right? And then we're going to do I++. So now the next index that I want to look at is index 1. And now we'll mess with the second character. All right? And so I want to continue this loop. I want to range through all the values from 0 to up to 3, right? I is less than or equal to 3. And so one way to do that is like I is less than, this is like the last index. How do we get that? Less than or equal to s dot size minus 1. Remember that? That's how you get the last index, regardless of the size of the string. And that's a lot of typing. We are lazy as computer scientists, so we've all agreed that it's easier, instead of saying I is less than or equal to s dot size minus 1, we've all agreed to say while I is less than s dot size. Less typing. Same thing. Well, it's strictly less than. That works too. It'll just never get to be 4, right? At that point. So while I is less than 4, that's what our condition is going to be. And that's s dot size. Okay. So that is going to be the process. So let's make it happen. My Zoom window is in a very weird place. Let me see if I can fix that, because I want everybody who's looking at the screen to be able to see it. Go hide yourself, please. There we go. All right. So let's remember the CC type library function. That's important. Here it is. Oh, I promised to stop attendance at like 50 minutes ago, sorry. You're all here now. CC type was here. And then here is to lower. You give it a character, it gives you back the lowercase version of that character. So let's do that now. We're going to make a new file called, just call it lowercase.cdp. That'll work. So I'm going to get string variables, so string library, and mess with them. I'm going to use to lower, so CC type. Alright, so let's ask the user for whatever their word is that they want to shout at us with all the capitals. So enter a word, and so I'll make space for that word, string s, read into the s variable, so with cn. We're going to get a single word by using cn. And so now our goal is to iterate through every valid index of s. And we want to replace each character, replacing each character with whatever its lowercase version is. Its lowercase equivalent, let's say. Alright, that's our goal. And so the very first index I want to mess with is index 0. It's always the first index of our strings. Index 0, and I want to go up until, I want to range up until I am 1 less than the size, right? Because that's the last index, size minus 1. So while I is less than s.size. So this will always work, no matter if the user typed like a giant word, it'll know its size. And then what do I want to do? At that index, I want to mess with the character there. So s at I want to change it to, well, whatever it is, but lowercase. So it's s at I, but lowercase, to lower. See that? That's how we want to change it. And then we want to work on the next index next. So this was index 0 that I just messed with. I want to mess with index 1 next, if it's there. So I++. And so now I is going to range from 0 to size minus 1. I'm going to touch every index of the string that exists. You see that? And so now if I print s, I will have a lowercase version of it. Alright. Lowercase is what we're calling this. So ask the user for a string, all caps blah, and we get lowercase blah. It went through every index. It changed every character. Print hello, watch this, hello, comma, space, world, exclamation point. That won't work because there's a space there, and darn, it won't. But I can do this, skip the space, and now it gets the whole thing. And it's going to lowercase all of the normal things that need to be lowercase. It'll keep everything else the same. To lower keeps, it just gives back the same character if it's like a comma or already an upper, or already a lowercase character. So yeah, it's going to go through that string no matter how big it is, because it's just going to size minus 1, whatever that happens to be. Here it's probably like 10. But for blah, it was up to index 3. Okay, any questions about that? So that's the while loop version. We good with that one? Because I should show you how to do the same thing with a for loop. Right? They can do the same stuff, so let's have that work. Let's not already do the work, so let's comment out the while loop version. And then let's add in the for loop. So, alright, it's really just read it off. It's just, alright, for what's the initialization? I starts at 0. For int I equals 0, my condition is the same, so while I is less than the size, I want to keep doing stuff. And then I want to increment 1 at a time, so I++. That's how I change things. And now just notice that the body becomes what I really want to do. What am I doing with I? That's what you put in the body of a for loop. Alright? So I ranges between among all the indices of the string s, and then I'm messing with each index, setting them to their lowercase characters. Okay? So, no matter how long your string is, it will go through it, iterate, and work. Make it all lowercase. Any questions about how I translated from while to for? It might be easier right now to just think of it one at a time and make the while loop form, but I do think the for loop will grow on you. Some things are better suited for for loops, some things are better suited for while loops. They are equivalent in power, though. All right. Any last questions about any of that? Because that's where I want to stop for the day as far as the lecture goes. Are we ready to hear about our next lab? All right. So let me release this. I'm going to give you 2 weeks to work on this lab. You're welcome. Due week 5, September 8th is when this will be due. Dun, dun, dun. So let's look at its write-up. All right, so this is all about conditionals, because I want to give you some time for loops to sink into your brain before I ask you to do loop labs. So let's do conditional labs. I'm going to do fuzz biz baz, what I call it, and then we're going to do a tic-tac-toe program as well. All right, so step 1, as usual, get the starter code. So let me go to that. Starter code 4002. All right. So here are your 2 files that you will get starter code. And let's do them. So the first one is just to take on the FizzBuzz example from class. I'm just making you do a fancier version of it, really. So it's just like FizzBuzz, but it's more involved. The comments of the file will tell you exactly what to do, but here's like a screenshot of the output that you should see. So let's look at the file, because that's where the instructions lie. So your job is to get a number from the user, just like we did with the normal FizzBuzz. And then here is the fuzz biz baz game, right? We're going to check for divisibility by 2, 3, and 5, all right? So if your number is divisible by 2, you're going to print fuzz. If it's divisible by 3, you're going to print biz. If it's divisible by 5, you're printing baz, and then every combination works as FizzBuzz does. So if it's divisible by 2 and 3, that's fuzz and biz, they're going to print fuzz biz. If it's divisible by 2 and 5, that's fuzz and baz, and you should be printing fuzz baz. If it's 3 and 5, then it's biz baz, all right? And then if it's divisible by all 3 of those numbers, 2, 3, and 5, then you print the whole thing, fuzz, biz, baz. Okay? Does that make sense? And then otherwise, just the same, print the number. Okay? So here are some examples. So like 2 is fuzz, 3 is biz, 6 is fuzz biz because it's 2 and 3 together, right? Then 10 is fuzz baz because it's 2 and 5 together. Then 11 is prime number, you just print the number. And then 30, which is like all of them at once, it's divisible by 2, divisible by 3, and divisible by 5. You print the fuzz biz baz. Okay, so that's going to be the program that you write. You're going to have to rearrange these, remember. You translate these into if statements and else ifs and stuff. There is also a trick you can read about, and I can help you with it. But I want you to do it the hard way first, at least. There is a cute little trick though that you can do it quickly, but I want you to do it this way first. All right. So that is your fuzz biz baz program. Any questions about that one? Very similar. You look at the FizzBuzz example from class; it should follow. That's that, and then compile as you know how. All right, the next one is about tic-tac-toe. So we're going to have the user enter in a tic-tac-toe board all on one line. So the user is going to enter in space-separated tic-tac-toe board where you're getting a row at a time, or like, here, let me try and explain. So the first 3 characters is the first row. The next 3 characters is the next row. The last 3 characters is the bottom row of a tic-tac-toe board. Because you can't get it in, I guess you could get it in a different way, but we're just going to get the whole board at once in order of rows. And then you're going to look at those characters that you just read from the user and determine if they correspond to a winning tic-tac-toe game. See if somebody won. So notice that X is the winner here because they got the diagonal. Your job is to check every way that somebody could have won and see if they did. Okay? So here's how you run the program. You're going to ask the user to enter the board, and you're going to get 9 characters from the user. And you can use that CN statement just a bunch of times to get in a bunch of character variables at once. So read into a bunch of space-separated variables. This is the line that you could use. You'll have to make 9 of them, though. So you're going to get every character that corresponds to all of the board elements. I think I've already given you the names that you should use, but you're going to get them all, and then it's your job to figure out if there was a winner. So you'll look for all the combinations, check all the rows, check all the columns, check all the diagonals. There will only be one winner in the tests. I'm not going to try and cheat like that or trick you, because It's impossible in tic-tac-toe to have multiple winners. So in this case, X wins, and so you'd print out X wins. For this tic-tac-toe board, you can draw it yourself, but apparently O wins for that one. And then if it's a game where nobody wins, like nobody got any of the rows, diagonals, or columns, then you're going to output it's a tie. All right? So your job is to determine the winner if there is one. Otherwise, output that it's a tie. All right? So it's a bit of a weird program, but it has a cool result. So here's the tic-tac-toe.cpp file. I've given you a few things. All right? I've actually checked all the rows for you, and so you can follow this pattern for the columns and the diagonals. But here's what I want you to do. I'm using these variables, and you need to make them and get them from the user. All right? So please use these variable names, get 9 characters from the user, and call them these. B11, B12, and they look like this. This is how they correspond on the tic-tac-toe board. All right? So get these characters in order. So read into B11, B12, then B13, then B21. It's like row 2, column 1, row 2, column 2, row 3, column 3. So that's all that. So read into those variables, use those names, because I've already given you some code that uses them. All right? So you can use this style of CN statement to get them all. And then once you have them, it's time to start checking things. So I'm going to keep track of the winner in a character variable, because why not? Because eventually it's going to be either like one of the characters that was in the board, and those are the board has character variables. So I'm just going to keep track of the winner with a character variable too. Set it to a question mark initially, because I don't know if there's a winner yet. And so here's how you can check the rows for a winner. So notice that somebody won on this row if these are all equal to each other, right? And you can't chain like you can in math, sadly. You can't be like B11 equals B12 equals B13. You can't do that in C++. You got to check, like, is this equal to this one? And then is also this one equal to this one? Something like that. So that's what's happening. Is B11 equal to B12? And is B12 also equal to B13? If so, they're all equal to each other. All right? If so, the winner is whoever was here. And you could save the winner as any one of these, because if they were all X, like, pick whichever one you want to save, that's the name of the winner. By definition, if we're in this body, they're all equal to each other. So I'll just save the winner as B11, but I could have used B12, right? Because they're all X's or O's or something. So that's how you can check the first row for a winner. I'm using separate if statements. Here's how you check the second row. Just check, hey, are these equal? And are these also equal to each other? If so, they're all equal to each other. And then the winner was one of the people on this line or something. It's one of those characters. And then the last row is exactly as you would expect. Just make sure all the last characters are equal to each other. If so, we found a winner, and here was their name. They were either X or O. They were in one of these, and they're all equal, so I'm just going to use this one and save that into winner. All right? So that's the syntax for how you might go about checking the rows. You already have that. I want you to do the same thing to check the columns to see if there's a winner, and check the diagonals to see if there's a winner. We all know how to play tic-tac-toe, right? You might have to look that up on Wikipedia if you don't. But that's the idea. And after you've done all of these checks, you may have found a winner. If you did, print out who won. Say like X1 or O1, depending on the character who won, who had 3 in a row. All right. So if somebody won, print who it was and say that they won. Otherwise, if it was a tie and nobody won, then I want you to notice that too and output a line saying that it was a tie. Okay? So I encourage you to make use of this winner variable like I was doing. That should help with the final output. All right? Any questions about this program? It's a bit more involved, so you're getting 2 weeks. There's a reason. But it shouldn't be too bad once you got all the pieces in place. Any questions about any of that? All right, so here's some, again, how the syntax might look, how the output should look. And the user's typing the board like this, just all on the same line if you want it. And then compile and run as you know how to do, and those are the 2 pieces of this lab. So you'll submit them both, the normal turn-in command, and this will be due in 2 weeks. All right? Any questions about either of those? Because that is your lab 2. We're good? All right. I think that's all I've got for you. So the rest of the time is yours to get started on this and ask questions, and we'll be here to help.